Okay, so today we're looking at combinations of transformations. So our learning intentions is the knowledge in translating and dilating different functions, and we will be successful if we can identify this formula, f of x equals k of f a of x plus b plus c, where k is your vertical dilation, a is your horizontal dilation, B is your horizontal translation, and C is your vertical translation. Okay, and we want to know what each section, how it affects the function. We'll be successful if we can calculate the equation of the translated or dilated function, and if we can correctly apply the order of translation dilations, and if we can calculate the domain and range after applying these transformations or dilations. So let us start. Okay. Let's look at this function, y. So that's our general form. Okay, we want to find the equation of each transformation if the parent graph of y equals x cubed is translated 3 units to the left. If that's the case, we'll get y equals, we're translating it to the left, so it's going to be x plus 3 cubed. Okay, now if we translate that 4 units down, you're going to get y equals x plus 3 in brackets cubed. Translating it down is going to be minus 4. Okay, what about if we do it the other way around? What about if we translate it down 4 units? Well, that's going to be y equals x cubed minus 4. And if we translate it 3 units to the left, we get y equals x plus 3 cubed minus 4, which actually gives us the same function. Okay, so when there's a horizontal and a vertical translation, so one of each, then the order is not important. We could have done the vertical translation and then the horizontal, or we could have done the horizontal then vertical. It's up to you. Okay. Example 2. Let's say we get y equals x squared. If we translate it up by 3 units, I'm going to get y equals x squared. Translating it up, we get plus 3. If I have a vertical dilation by a scale factor of 5, so vertical, I'm going to get y equals 5 lots of x squared plus 3. Yeah, so that all the y values, have a scale factor of 5. Okay. What if I do this? What if I do it the other way around? What if I do the vertical dilation first? So if I do the vertical dilation first, I get y equals 5 x squared. And if I translate that up by 3 units, I then get y equals 5x squared plus 3. Alright, these functions are not the same. So note that when there is both a vertical translation and a dilation at the same time, or a horizontal translation then a dilation, so when it's both vertical or both horizontal, then order is important. So be very careful of that. Okay. Another example. Let's translate y equals x cubed with a horizontal dilation of scale factor 1/2. So if that's the case, we're going to have y equals 2x all cubed. Yeah, because we do a reciprocal. Okay. Then if we translate it to the left by 4, we're going to get we're going to translate it to the left. We're going to get x minus 4 cubed. Yep. Let's try the other way around. If we have a horizontal translation to the left by 4, we would actually get x minus 4 all cubed. Okay, and then to apply the horizontal dilation of scale factor of 1/2, we'll get y equals 2x minus 4 all cubed. Yeah, so once again, these are not the same. Yeah, so doing a horizontal translation first is going to give you f of x, a, x plus b. So horizontal translation, so as you can see here. Yeah, so horizontal translation, then dilation. If you did a horizontal dilation first, we're going to give you a, x plus b, as in this example. All right. So note, when you get y equals k, f a of x plus b plus c, try to remember to do the horizontal dilations first, and then the horizontal translation. So a before b. Then do the vertical dilations, and then the vertical translation, kc. So try doing it kind of alphabetical, so a, b, k, c. Okay. Alright, so we're going to describe the transformations of our parent graph of y equals x squared in the correct order. Okay. So here I have 4x squared minus 1. If we, what we're going to do first, we're going to do the vertical dilation of 4. Yeah, and then we're going to translate that whole function down. Yeah, because remember, if we did it the other way around, so that would give us if we translate it down, it would give us x squared minus 1, and then it will have a 4 out the side. Okay, which is not what we want. Okay. Here we've got to do, so we've got a horizontal translation and a vertical translation. So it doesn't really matter which one we do first. So let's do the horizontal. So B before C, horizontal translation. And we're going to the right. And I'm going to have a vertical translation up by 1 unit. Okay. Here we've got everything happening. So we've got your K, your A, we've got a B, and we've got a C. Okay, the only problem here is that we don't have it really in this order of y equals k f of a x plus b. Okay, plus c. The a is kind of inside. So really, going back to this note, we've got that type of thing. So we're going to do a horizontal translation first. Okay. So we've got a horizontal translation to the left, yeah, by 4 units. Then we have horizontal dilation of 5 unit, scale factor 1/5. Then we're going to have a vertical dilation of scale factor 2 and a vertical translation. Down by 3 units. Okay, so just be conscious about this type of thing. Yep, so when you see the AX plus B all inside the bracket, then that's a horizontal translation. If I had a factor outside, and say, for example, if it looked like y equals 5x plus, so let me take the factor of 4. Sorry. So I want to get 4. Right. Minus 3, that would give us your vertical dilation of 2, a horizontal dilation of 1/5, a horizontal translation of 4/5, and then a vertical translation of -3. Okay, so be careful of that type of what's happening in the center of the brackets. Alright, so let's describe the transformations in our correct order for these ones. Okay, yep, so the scale factor is 1/2, so that's not going to really bother. So we're going to do a horizontal dilation. Really is 1. So it doesn't matter, we didn't have to write that down. A horizontal translation to the left by 3 units. A vertical dilation of scale factor 2 and a vertical translation down by 1 unit. Okay, alright. So here we have, so we're going to have a horizontal translation to the right by 4 units. Okay, we've got a vertical dilation scale factor of 3 and a vertical translation up by 3 units. Okay, so here we have the A on the outside, so we definitely have a horizontal dilation of scale factor a third. We get a horizontal translation. To the left by 1 unit. We've got a vertical dilation of a half and a vertical translation down by 4 units. Okay. Alright. Okay. We want to find this example. We want to find the equation of the transform function using the correct order transformations. So there's our original format. Okay. If we've got f of x 1 over x, it's reflected in the y-axis, then translated up 3 units, and then dilated vertically by a scale factor of 9. We're going to apply that slowly. Okay, let's do the first part of reflecting it in the y-axis. If we reflect in the y-axis, we get negative 1 over x. There's your reflection. If we're then going to translate it up 3 units, we're going to, that's that plus c, so we're going to have plus 3. That's the translation vertically. And now if we're going to dilate it, so we're going to dilate this whole thing by a scale factor of 9, we get the 9 on the outside. Okay, so technically the original function would be negative 9 over x plus 27. Okay, so let's look at the next example. We've got y equals x squared. We're going to translate it up by 6 units. Then we're going to translate it to the left by 2 units. And then horizontally dilate that with a scale factor of a third. Okay. So if we translate it up by 6 units, we get x squared plus 6. That's the vertical translation. Okay. We're then going to translate that 2 units to the left. So we get x plus 2, all squared plus 6. Yeah, so that's a horizontal and a vertical translation. Okay, now we have a horizontal dilation with a scale factor of a third. So dilation happening after the translation, we're going to get 3x squared plus 2, all squared. So because the scale factor is a third, so I'm going to reciprocate that. It's going to be 3. So this is where the dilation is happening after translation. Yeah, so we get 3x squared plus 2 plus 6. Okay. Okay. Alright. A few more examples. So we want to find the domain and range of these functions. So we're going to start with this one, x plus 3 squared. And what I'm going to do is I'm going to write my original, I guess, in pencils. So if my original function is y equals x squared, then the domain, is negative infinity to infinity. And the range was from 0 to 5, 0 to infinity. Okay. If I move it 3 units to the left and then up 5 units, the domain doesn't change. However, the range now starts at 5, but still goes to infinity. Okay. Here we get our parent tree of y equals absolute of x. Well, then that's domain is still the same. It's like negative infinity to infinity. And the range is from 0 to infinity. Well, if we have a horizontal dilation of 3 and the vertical dilation of 6. It's really narrow. But if we translate it down, the new domain is still negative infinity to infinity, but the range has changed from negative 2 to infinity. Alright. Here we have the absolute, like 1 over x. And the domain for that is from negative infinity to infinity, but x cannot equal 0. Yeah, and the range was the same. It was negative infinity to infinity, but y cannot equal 0. But here, if I look at the range now, the range has moved up 3 units. So technically the range is going to go from negative infinity to infinity, but y can't equal 3. And the domain, okay, this can't be 0. So if I solve that, like 2x minus 8 equals 0, 2x equals 8, x equals 4. So it's going to go from negative infinity to infinity, but x can't equal 4. Okay, and that's the range for that. Alright. So we're going to now find the coordinates of the image. We got y, because we got xy, and it's somewhere on the function. And if we're going to transform the function, okay, so here we have, if a equals 3, so if I write it out, k is 7, a is 3, x minus 6 minus 4. Okay. So if I start with x and y, I'm going to move them. Okay. The inside stuff, the a and the b, will change the x coordinates. Okay, so what happens is I get, remember it's a scale factor of a third, so it's going to be a third times x, and then I'm going to add 6 to this. Okay, so my new coordinate is going to be a third x plus 6. Okay, my y are the outside, the k and the c. So what I'm going to do is I multiply it by y, and I'm going to minus it, move it down. So my new coordinates become 7y minus 4. Okay, let's try this example. Alright, we get y equals a half of a third, x minus 7 minus 5. I start with my x and y coordinates. Okay, I'm looking at the inside brackets. I'm going to do the opposite. So if it's a third, I'm going to times it by 3, and I'm going to add 7 to it. So when looking at the middle part, x's, we're going to do the opposite. The y's, we're going to take the outside terms. So it's going to be a half of y, and it's going to be minus 5. Okay, so when translating, the a and b situations are inside the brackets, and that will change the x coordinates. And the k and c will change their outside, and that will change the y coordinates. Be careful when you're dealing with the x's, because we're going to do the opposite. Okay, if a is 3, then it's a scale factor of a third. If it's plus b, we're actually going to subtract the units from that. Okay, thank you very much.